See the slide, right?
Yes.
So with that, let me say thank you, Maxime, for that orientation, and the polls helped a lot. Thank you for the opportunity to present this work on what we call driver-assisted truck platooning. As many of you know, I'm a consultant working in the intelligent vehicles industry, and in this case, I'm a subcontractor to Auburn University, which is the prime contractor here. And as you see from the screen, we have also a very impressive team. Peterbilt, the truck manufacturer, is supporting us. Peloton Technology is a startup company focused on this type of functionality for commercialization. ATRI, the American Transportation Research Institute, is very well known in the U.S. and worldwide, I think, as a research organization for the trucking industry, and it's under the umbrella of the American Trucking Association. Meritor-Wabco is a supplier of trucking components primarily, including radar and camera-based active safety systems. And the work is centered in what's called the GPS and Vehicle Dynamics Laboratory in Auburn University. Overall, this is all sponsored by the Federal Highway Administration. I'll say more about that in a moment. Also, I'm pleased that from looking at the list of attendees, two of my partners are on the call today, Josh Schwitkus, who's the CEO of Peloton, and Lisa Park with ATRI. Maxime, if you could monitor and if they make a request to speak up using the microphone and make an additional comment, that would be great if that's possible. So Josh and Lisa, you could send a note to the organizers if you'd like to make an additional comment, which I would very much welcome anytime. So with that, let me proceed. Here we go. Just a quick project overview. This activity is part of the Federal Highway Administration Exploratory Advanced Research program, which has been running for several years now, looking out beyond the next generation, the generation after next, across a wide variety of topics. So I recommend you check that out on FHWA's website. And a solicitation last year focused specifically on partial automation for truck platooning. And so we brought our team together and were awarded this project, approximately $1 million in funding plus cost share from the participants, and you can see it runs from late last year actually through 2016. So, and if you look at the bottom of the slide, our focus is very much on go-to-market. It is research, but our real focus here is to say, okay, truck platooning's been done before. What does it take for the trucking industry to really see this, understand it, see that it fits within their operational activities, and address whatever concerns need to be addressed to take this into usage in the trucking industry. So as I, sort of frame the issue, here we go. There are several benefits, and I'll get into that further, but when it comes to trucks moving, operating closer to one another, it's all about aerodynamic drag and reducing that drag. As you can see from this image, something on the order of 12% highway fuel savings. It depends, of course, on the parameters, the inter-vehicle distance, and that kind of thing, which is a huge aspect of cost to trucking fleets, and so it's a direct contributor to fleet profits if fuel economy can be increased. So that's a key aspect of what we're doing here, as well as associated safety and traffic flow benefits. But as you can see from the very top, aerodynamic drag for a typical truck, a tractor-trailer configuration such as this, at 65 miles an hour is responsible for 65% of the fuel use. So it's a really huge component. So with that, moving to our fundamental research hypothesis that this is a technology that's ready for industrial use, ready for commercialization. As I said, it's been prototyped for many years now. and that it will provide value in specific roadway and operating conditions for heavy truck fleet operations. And we want to understand what those roadway and operating conditions are. So that's a hypothesis as we go into this. We don't know if it's ready. We'll engage with the industry and work the technology side, and that's the point of the project. The implementation focus is quite simple. If you've been following this part of the industry for a while, the focus is not on full automation. We feel that that has a future, but that as a much more near-term stepping stone, a simpler system is more ready to go for commercialization, and that's with longitudinal control only, and only 2 truck pairs. So the idea here is to use V2V Communications to exchange performance data between the vehicles so that particularly braking information can be sent instantaneously from the front truck to the rear truck. And because of that ability for the rear truck to respond quickly, the inter-vehicle distance can be shortened to get the aerodynamic benefit. Positioning is also essential here, so that the communications that are being received by the rear truck are truly from the truck immediately in front. So discrimination between the in-lane communications and any out-of-lane communications has to be sufficient for that. And certainly the human-machine interface is important. This is a new mode for truckers, and so that has to be well designed, and that's part of the focus in the work as well. Just a quick look at the technology package. We see this as a tractor-only installation. The complexity of a system like this would grow exponentially if it had to be on the trailers as well. So it's a tractor-only installation. The typical sorts of things, you see the radar unit, a typical sort of adaptive cruise control radar unit here. System control electronics, active braking system, acceleration control within the engine or vehicle controller, a camera somewhere right behind the windshield, possibly an indicator that the vehicle is under platoon. That'll be evaluated. And then the antennas, this particular diagram shows it sort of at this spot on the truck. I think we're looking that maybe the antennas need to be on the side mirror, and possibly both side mirrors, in order to for the signal to be received beyond the trailer, so the signal is not blocked by the trailer. But that again is something that will be investigated. So really what we're building upon here is the classic adaptive cruise control that's been on the market for some years for both cars and trucks, and commercial radars for that purpose, and then we're adding the V2V communication for what is commonly called cooperative adaptive cruise control. So as we engage with the trucking industry, there's a wide range of questions here, and so here's a partial list. It's all very, very operationally focused. So how can my driver find another equipped vehicle? And if I do, how do I know that other vehicle is trustworthy? How do I know their equipment works properly? How robust is the system? Of course, that's an obvious question. Robustness includes something like a very severe braking by the front truck. The rear truck cannot collide into it. So how robust is that process? There are questions for the following driver, retaining situational awareness. That driver's job is to steer but not control the throttle and brake. What are the issues that come up there? And for the lead driver as well, does that driver's job change, and if so, how does it change? There certainly will be anomalies such as cut-ins from passenger cars. It does happen. We've seen in other projects such as the Convoy project in Europe, even with fairly small gaps, passenger cars will cut in. How does the system react robustly to that? And then at the business level, there's the question of return on investment, coming back to that fuel economy benefit. And then this last question, can the system adapt properly to changes in load? The ideal operational mode, just based on the physics, is if the heavier truck is in the front and the lighter truck is in the back, because that means the lighter truck has a shorter stopping distance. So this is just a sample of questions we'll be looking at, and the project aim when we sum it all up is, what does it take for the trucking industry to adopt this idea of DATP, and what settings and what circumstances. Most likely, certainly for the first generation system, it'll fit a segment of the trucking industry, but not the entire industry. So with that, Maxime, why don't we go to the first poll? I want to just ask the group about the main benefits of something like this as they see it.
So yes, let's launch the first poll. So you should see in front of you what are the main benefits of DATP. So you can select only one there. I'm sure that there are more than that. And so road safety, fuel economy, traffic flow efficiency, driver comfort, and fleet operator branding. It would have been good to have more than one. I'm sure that people would have.
Yeah, it was sort of intentional on my part
possible.
To sort of force a, you know, what's the main benefit.
Okay, so we have 83% who answered. So I close that and share it with everyone. And clearly, fuel economy is the main one. Then we have also some people thinking that traffic flow efficiency will be best, and road safety seems to be also
certainly
focused.
Certainly.
But still, the driver comfort and operator branding might be something interesting. And if we would have a multi-answer question, so then we could have seen some of people voting for that one. So. Okay, so I'll hide that one, and actually we have one question in the that is quite relevant to your description in slide 6, I think. It was, I'll hide this, and then it was asking if we could do this technology only with V2V, or do we need the different sensors that you have described?
Okay, only with V2V. I'm not the best guy to answer that, so Josh Switkus might want to provide a comment. But from my experience, I would think that you need both, because you certainly always have the possibility of dropout of the V2V communications, and you know, you need some redundancy in the sensing.
Should I give the voice to?
Yeah, Josh, if you're up for that. Kind of a surprise. Otherwise, we can just keep going.
Yeah. Hello.
Yeah, Josh. Good.
Yeah. So the radar and the V2V I would say make an excellent combination of sensors, because they're complementary. So the radar gives by far the best measurement of the distance and the relative speed between the vehicles. With vehicle to vehicle, you can get a rough measurement of distance, you know, just difference in GPS. But the radar gives a much smoother, much more accurate measurement of that distance. So for these tight following distances, it's especially important to have a very smooth and very, you know, fast reacting controller, partially for driver comfort, partially for safety, and then also for fuel economy. If you if you tried, and I have not tried to do this with purely DSOC, but if you did, you would have to be very aggressive in your controller. And so while you might still have aerodynamic improvements, your engine efficiency would go down significantly. In addition to all of that, from a safety standpoint, the combination of radar and DSOC is excellent, because if you have an issue with one of them, you can use the other one to safely separate the trucks. So for example, if you lose DSRC communication for some reason, now you have the radar sensor to tell you that, okay, it is not an emergency braking situation, unless it actually is, and so you can smoothly separate the trucks. If you had only DSRC, for example, if it went down, you would, from a safety standpoint, you would have to assume the worst case and start braking that rear truck, which of course is not desirable in most cases. So maybe a long answer to say that it's important to have both sensors, and they work really well together.
Okay, that's great. That's a great answer, Josh. Thanks.
Yep.
Okay, so I'll continue here to just speak to the schedule of the project. We're now in phase 1, which is initial preliminary sorts of examinations. We've drafted a concept of operations document. We'll be examining the business case and doing some initial technology performance evaluation in order to develop the system requirements. So I'd say the system requirements are a major output as well as the business analysis. We'll also be doing traffic simulations to understand how this might affect traffic flow, particularly on congested freeways. There are some freeways in the U.S., Interstate 81 in Virginia, for instance, and Interstate 95 going down the East Coast, that have extremely high truck densities there. So if the inter-vehicle distance is brought together, you can at least theorize that that improves traffic flow. It helps traffic, but we'll be doing some simulations there. Then phase 2, which may or may not be awarded, by federal highways, that's up to them. We'll implement the prototype system and then do some very extensive evaluations on a large test track, a 2-mile oval test track that's at Auburn University, as well as the public highways in the area, interstate highways, working with professional truck drivers. So that'll give us the opportunity to assess the technical performance. We'll be looking at the robustness, for instance, extreme maneuvers, that kind of thing. We'll be measuring benefits in terms of fuel economy and working the driver acceptance issue, our user acceptance. So it's both the drivers and the fleets, the trucking fleets. Phase 3 would be a small effort to disseminate the results, sort of lead to next steps. So let me tell you, now that I've given you an overview of the overall project, recent activities and some early results, we have developed this concept of operations just to describe what this is all about. It's currently under review. We also were able to attend a meeting called the American Trucking Association Technology and Maintenance Council, and this is where truck technology gets discussed by experts from various trucking fleets. Perfect place for presenting this kind of information. So they actually have a DSRC task force in which we presented the DATP concept that was presented by Lisa Park of ATRI. Josh was there as well, and it was the first time within the project, at least, to get some good back and forth interaction, get some questions from the truck players, partly to at least explain what Josh was just saying, how V2V really does enable a closer following distance that's still a safe following distance in terms of braking. And that's not a simple concept that you might get right away, especially if you're not a technical person. So that required some back and forth in that meeting. Also, the Technology and Maintenance Council has recently established a new task force called the Automated and Connected Truck Technologies Task Force, and we'll be active within that. Actually, they recruited me to be the chair of that task force, so anyone on this call who's interested in participating in that, please let me know. And we've also taken steps to get an initial read from the trucking industry on this idea of DATP. And one aspect of developing that survey was to create this new name. Us guys who've been in this for a while have called it Cooperative Adaptive Cruise Control, which is a bit of a mouthful. So the question was, what's a more descriptive term? And we decided this idea of driver-assisted platooning, driver-assisted truck platooning is a term that communicates immediately to the trucking industry what this is all about. So let me tell you a little bit about that. I'll go through this slide and then we'll have another poll. One of the aspects in the ConOps was to really extrapolate, elaborate on the linking scenarios. How do two trucks find each other to do the linking? Clearly there will be a very small percentage of trucks on the road initially that have this technology. So one approach is pre-pairing is one thing to call it. The trucks leave a terminal together. So this is more likely to be within a situation where it's company controlled, it's the company trucks. You can see for parcel carriers this is common, as well as what we call less than truckload, meaning truck fleets that carry cargo for various different customers, and so they're always loading and unloading parts of their load. And notice private fleets also is 50% of all trucking companies, and so if you think of Walmart or Pepsi and lots of players like that, they move their own goods around, and within a private fleet they have very large distribution centers, and so for trucks to be dispatched together on a similar route is not unusual. And so in this scenario the trucks would be sort of assigned to each other, and then the actual linking would happen once on the highway. Of course, the other way to do it is ad hoc. The trucks just find each other on the road, probably with some sort of third-party clearinghouse. Could be an app, you know, there's various ways to do this, and then they would have to adjust speed somewhat, you know, for one to catch up with the other. How much time and trouble that is a question we're investigating, and how acceptable that might be. And then a third way is a kiosk approach, where at truck stops truckers could sort of sign in to a kiosk and say, hey, I'm on my rest break, I'm going to leave in 8 hours, and if somebody wants to pair up with me, I'm going from Chicago to Pittsburgh, you know, let me know. So that's a possibility too, and so we're going to look at all of these type scenarios. One of the key questions as we do this will be comfort and operational issues of linking within your own fleet, which means you have to have a big fleet. There's plenty of big fleets, so that could be feasible. Or would you be comfortable as a trucking fleet linking your truck with trucks from other fleets? So these are the type of operational questions that are out there. So with that, let's go to the next poll, which actually addresses this linking approach.
Okay.
Just to get your feedback on that.
So I'm launching the next poll. It's what linking approach appear to be feasible, and the three options that Richard just explained: assign linking partners at distribution center, linking partners find each other and then use a clearinghouse approach, and then the last option is linking partners find each other at the kiosk, etc. And
you can vote for more than one.
Yeah. So we have only 48% voted. The text is long, so it seems that people take their time to pick the right approach. And 67, so I'll stop at 75, so just a few more. Okay, and then I stop now the poll, so make your choice, and then I share it, and I'm not sure you see it, Richard.
Yeah,
so
I do.
You see it on the side of 63% for the first option, 52% for the second one, and then 33. Do you want to comment?
Yeah, and if Lisa and Josh want to say anything about this, we're seeing, you know, openness so far, at least, to all three approaches, and it really depends on the nature of the trucking operation. So certainly, my personal feeling is it does seem to make sense for the number one option of assigning linking partners at distribution centers. Seems to be the most straightforward. But we'll see as we go forward.
Great. I have a question here. So for the audience, don't hesitate to write up your question. We will try to answer most of them. I have two questions on the same topic. But first, it says, does the lead tractor lose efficiency? And then the second one that would be linked is, how do you envision that the distribution of benefits, that there is a distribution of benefits amongst the platooning vehicles?
Yeah. So first of all, on the physics, the aerodynamic benefits happens for both the front truck and the rear truck because there's less turbulence behind the front truck. So I'll show some numbers later, but the front truck does get a fuel economy benefit. But they are not equal benefits, so you could certainly ask the question in terms of distribution of benefits. How do you decide who's in the front and who's in the back if they're loaded equally and they're not with the same fleet? Open question right now. Was there another aspect of the questions, Maxine?
No, so I think you answered both, and
okay.
There was another question, more technical. How do you know the trailer length if you're not taking into account in your installation this trailer?
Yeah, Josh, can you speak to that? How do you know the trailer length, or how does that factor in?
Yeah, sure, and that's another. It goes back to the previous question. I'd say actually it's a great application of combining DSRC and radar, and so it's possible from that to basically from DSRC you know the tractor, well, the location of your GPS antenna, usually in the center of the tractor, and then from radar you have a number of targets on the road, and you can discriminate which one is the rear of that trailer by combining the distance and the motion of that trailer. So in other words, you know the speed from DSRC, you know the location of the tractor, and now you can discern which target is the rear of the trailer, and now you know the length of that trailer moving on from that point in time.
Great, good.
Great, thank you, Josh. So I give you, I have to stop this poll, and then you have, you have the floor. Okay.
So let me now get into this the survey that ATRI developed for us. That we call a convenience survey, and that's a very important term because it's not intended as a scientific survey with all of the large number of respondents needed for that. It's to get an indicator of what the trucking industry attitudes are at this time based on what they understand about the system. So it was focused on both motor carriers and drivers. Motor carriers is probably more of an American term, but it's the term for a trucking fleet that moves cargo around. And so we addressed in this survey, general usage of precursor technology such as adaptive cruise control, initial reactions to this idea of DATP, perceptions of user benefit, and driver willingness to use the system. All with the caveat that this is a very new concept and it's maybe not understood immediately. So we understand that these are questions we'll have to ask at several points along the way after the understanding is a little deeper. Nevertheless, we think it's important at this stage to sort of draw a baseline. And obviously the perceptions and opinions that we got focused on safety, fleet efficiency, litigation, the cost or payback period, and operational issues. So let me give you a feeling for some of these results. Certainly at the very high level, both the carriers and drivers at this point in the game are comfortable with technology and use DATP-related technologies such as adaptive cruise control. Adaptive cruise control has been in the truck market in the U.S. for over 10 years, I would say, at this point. And here we go. In terms of the question was how might a DATP affect safety performance? So here you see that 54% of the carriers were unsure about that, and 40% of the drivers. And we framed the question that way because you know, there's they weren't presented any data in terms of this at this point. So our takeaway from that is clearly, you know, we knew we would be defining system requirements for safety in an objective sense, a technical sense, but I think it's important to also do that subjectively to understand what it takes for fleet managers and drivers to subjectively feel the system is safe. So a few other items. What about the payback period? We had a very clear response here. You know, this was really more for the carriers. They're looking for a 24-month, I guess that would be a maximum payback period, not minimum, for a system like this. And I think that's not unusual for other truck technology as well. So 87% is pretty just defining number. In terms of benefits, we asked about operational efficiency. 30 drivers, you know, felt that there would be a benefit there, 30% of drivers. And then the question was, well, what if the drivers are unwilling to use DATP? Well, this was certainly a concern for 44% of the carriers. And here's this question of what about using DATP in tandem with a competitor, not only a company that you don't, you know, you don't have a direct connection to that company, but they may be an active competitor. And to me, this was a higher number than I expected. 49% are comfortable with that, 28% uncomfortable. And then there's this question of linking, if you're finding other trucks on the road, there's the possibility for delay. You know, that's not a trivial amount. 39% to link with another truck, which is sort of a larger operational disruption, but 6% would consider that. So some interesting initial concepts there. So let's go to the next poll, Maxime.
Yeah,
Maxime,
so we experience some technical disturbance. Yeah, I'm there.
Okay.
So, but I think that, yeah, we can go to the next poll, and so looking at what are the operational modes of DATP, which are feasible. So DATP with trucks from a single fleet commercial, and vehicles from multiple commercial fleet, and also many equipped vehicles, more than just trucks. So it would be DA something, DAVP then. So of course, there we have 49% of respondent, 51. So you're taking your time. We still have 15 seconds, so we reach 70%. So okay, so I'll close the poll and share it with all of us. I guess you see it, Richard. So 29% for the single commercial fleet operation, and then 55% with multiple, and then other vehicles cooperation 16% only. Do you want to comment?
Yeah, that's interesting. I think you know, we have a lot to learn about that because this is a new operational mode, but it will probably come down to, you know, what works operationally as opposed to whether that truck's in my fleet or not. But of course that depends on standards, you know, ways to trust what that other truck is carrying. All right, well, let's keep going. I have one question which is relevant there.
in any case of an accident, who is responsible, the lead truck or the back, the one in the back, etc. If you want, we can keep that one for later. Up to you.
Yeah, let's defer that to a little later.
Okay. So
okay.
I give you the floor.
All right.
Here we go.
So we asked the question just in general, subjectively, what factors would increase the carrier's comfort? Resolving safety and litigation issues, that's perfect for that question that was just presented. Demonstrating clear benefits, of course, and reasonable costs. So again, this is indicative of what's on the minds of these folks. And now we're going to go to another poll, which is, and then I'll show you some results from the our survey relating to this poll. But go ahead with this one, Maxime. It's focused on the fuel efficiency benefit. Our last poll.
Yes. So last poll, and let me put this up. Launch. Here you are.
So it's sort of the question of, if you're running a truck fleet, and maybe some of you are directly involved in this area, what's compelling, to maybe adjust your operational mode and get some new technology? What does it take to motivate you?
I can tell you that right away we got many people voting for more than 10%, but I guess this is now adjusting, I can see. So, okay, we have 10 more seconds, or 15. So,
yeah, it's almost in thirds here.
Okay.
I will, yeah.
Everyone voted.
I will say in the U.S. Well, go ahead, Maxime. Why don't you summarize?
Yeah. Okay. Share it with you. Oops. There we go. I'm not sure we can see very well the greater than 10%, but anyway, the numbers are written on the right. So 66% at least would need 5%.
Yeah. Right. So in the U.S. trucking industry that I'm very familiar with, 1 or 2% demonstrated fuel economy is very interesting to truckers, and that's why we're seeing aerodynamic skirts, as they call it, and other treatments, maybe tire treatments, that kind of thing. So let me show you what our survey resulted in. Well, first of all, these first two bullets, in terms of desired outcomes from the different players, you see the focus on safety as the first bullet, increased driver efficiency, not as strong of a focus, but it's still there. And then the fuel efficiency, first of all, just in terms of the general idea of fuel efficiency, is that a desired outcome? And you see 67% of carriers say yes, 54% of drivers. And then we get to the specific question that I just posed to the group. So 0 to 5%, as we framed it, 52% of carriers said that would be required for them to move. But 31% required more than that, up to 10%, and then 17% required more than a 10% increase. And so if you combine these first two, if you can get to 10%, then we're at 83% of carriers, at least in terms of this group of respondents, which is, that's a very significant group, even if we don't get above 10%. So with that, let me tell you about some fuel economy testing that was actually done prior to the project, but is feeding into the project. And I'll go through this, and Josh, ask you to comment in any additional way. This was done just last October in Utah on an interstate there. 2 trucks moving at 100 kilometers per hour with an 11-meter gap. There's a very formal and well-defined test protocol, the SAE J1321, that was used and implemented by third-party players. So the vehicles under test were assessed in terms of fuel economy, and there was also a control truck with none of the equipment that was also operating at essentially the same time and on the same roads. The way this was done was 6 40-mile segments, and the results were combined on Interstate 80. The vehicles were 2011 model Peterbilt 386s, a typical Class 8 tractor for U.S. use. Here's the fuel savings. So at this gap, the lead truck experienced a 4.5% fuel savings, following truck 10%. 11 meters is, the main factor that addresses this. The one thing we'll be looking at in the project is the potential for closer gaps. That's certainly doable technically, or further gaps if there's driver acceptance issues or any other sorts of issues. So that gap, both at a technical level and an overall fleet efficiency level, will be a key part of what we'll be evaluating. You see in the text box on the right there's a report that fully describes this testing, and it's available online. Josh, would you like to add anything here?
No, I think that was an excellent summary. I guess just a couple of comments. This was going back to the poll about what fuel economy increase is meaningful. These savings were the largest that C.R. England had measured from any add-on device. So these are, for a typical U.S.-based trucking operation, they might spend $100,000 a year per truck on diesel fuel. Our diesel is cheaper than in Europe, but the miles tend to be longer for these long-haul trucks. So just these fuel savings could potentially double the profits of a fleet, and that's why fleets are so interested in this type of technology.
Yeah, and you mentioned the fleet, but why don't you explain a little bit who they are?
Oh yeah, so yeah, it was a Utah-based fleet named C.R. England. They are, despite the name England, they are purely U.S.-based, and they are a very well-respected fleet. They've been involved in the leadership of the American Trucking Association for a long time. Other fleets look to them for what they test, what they implement, and so on. And they are somewhat unique in that they have this excellent test program. Many fleets here do not have a team testing new technologies, so they look to other fleets, and they look to projects like this project that Richard is describing today to see what technologies they should adopt. But C.R. England is definitely a leader in that respect. They're constantly doing these types of tests on various technologies.
Great, thank you. And so let me wrap up here. Just our near-term plans. We have a lot of work starting up. An industry operations panel is being created by ATRI, and with Peloton and Auburn, we'll be getting more stakeholder input there. At Auburn, there's an operations research professor who's going to look at these platooning opportunities that can be found in the ad hoc approach. We will, of course, be getting into the truck technology performance aspect, instrumenting the trucks, analyzing inertial and radar data, and working very intensively looking at the positioning question between the two vehicles using V2V Communications. We've done work in that area before, and so we want to refine that. There'll be further aerodynamics modeling to understand the issues there. And the wireless engineering group within Auburn will be looking at, in particular, at the performance of 5.9 gigahertz antennas on truck pairs and those questions of optimum antenna placement. So that's just some of our near-term plans. And that's it. Again, I want to acknowledge the Federal Highway Administration for sponsoring this work. Dr. David Beverly at Auburn leads the activity for Auburn. Josh, of course, is key here. Myself, and as I said, Lisa Park of ATRI. And Lisa, if you'd like to add anything about any of this right now, please feel free. So with that, Maxime, we can take questions.
Yes, so I already gave you one question that was quite relevant, but I have another one here. Has the CONOPS been published by Auburn and or the Federal Highway Agency?
No, still under review, so I don't have a date for you on that. Maybe within a few months, something like that. And on the question of liability, Josh, can I throw that one to you? Because I know you've gotten that question before.
Sure, yeah, and of course I'm answering based on U.S. liability law. I will be very clear. I'm certainly not an expert on European liability law, so it may be very different. In the U.S., liability is shared. So in other words, it's not in any type of accident, it's not a question of who is at fault. It's a question of how much is each party at fault. And so in traffic accidents, the potential parties at fault are always the drivers and fleets of the trucks, potentially the truck manufacturers and the suppliers. So, the job of a supplier of a DATP type of system is to make sure that it is genuinely safe, so that the accident will not occur or will not be caused by the system. And then there's also a very interesting aspect here that this type of system can document extremely well what occurs before and during an accident. So then, there is documentation to show that either the system was not on or the system was on and the accident was unavoidable. Or, even more interestingly, it can document the accidents that this type of system prevents. So that very quickly, in a fleet operation, it can be seen how many accidents are prevented, which is something today there's not a lot of good data on. So, so the original question was, who's at fault, the front truck or the rear truck? The answer is it's the same situation as with any manual driving. It can be a combination of the two. It just depends on the situation. But the key thing to remember is that this type of system can dramatically reduce those frontal collisions, especially, so that it becomes generally not an issue. So I know that's maybe not a black and white answer, but maybe that lays out kind of the situation.
That's great. Thanks.
Okay, we have another question. We are soon at the end of the webinar. So there is a question on the road infrastructure, and should there be separate lanes for platooning vehicles? And then another question from the same person on what is the maximum allowed distance between two vehicles in a platoon? That was
okay. In terms of the road infrastructure, we're open to receiving comments on that as we engage with the trucking industry. All the discussions so far have focused on mixed operations, mixed traffic. So nothing in the way of an exclusive lane specifically for these trucks. And what I always say, and then this is just speaking personally, is if we require the infrastructure authorities to make modifications or even policy modifications to reserve a certain lane, the commercial potential sort of is greatly reduced. So the overall focus here is on a system that operates in the regular lanes with regular traffic. As to the maximum following distance, Josh, let me throw that one to you.
Yeah, so the this type of the range of the radar and the range of the DSRC are large enough that from a technical standpoint you can be very far apart. But with the typical antennas used for trucks for DSRC, you can be a kilometer apart. And radar is of course not quite that range. But in practice, you generally don't want to be that far apart because you'll just have vehicles cutting in between you constantly. So Richard mentioned cut-ins earlier. One of the things we were struck by when one of the first fleets we talked to about this type of system the fleet manager who has his own commercial driver's license, said to us, I think that one of the benefits to drivers will be that they won't have to worry about cut-ins as much because most cars will not cut in when the trucks are close together. Our testing on the highway, we have absolutely seen that to be the case. Cut-ins are extremely rare. We drove a few thousand miles without a cut-in recently on the way to Utah. So cut-ins can still occur, and we need to react. But in general, that's a benefit of actually being closer. Now, I will say, depending on conditions, you may want to have the trucks farther apart. So if potentially for bad weather, either rain or snow, or in certain types of traffic. The beauty of this type of system is in software you can just set that distance based on any inputs you want, conditions, the traffic or weather or so on. So we've been testing mostly from 75, from 20, maybe 22 meters down to, we've done a few tests down at 3 meters. And it looks like the sweet spot is kind of in the 11 to 15 meter range. That's where the driver is very comfortable, the fuel savings are large, you don't get cut-ins, and so on.
And I'm sure, the driver comfort is something that would evolve over time so that they may be comfortable with shorter gaps after, a couple of years or something. Maxime, let me respond to a question that hasn't been asked because it gets asked in other situations. The flip side of the fewer cut-ins by passenger cars is, what if you're in that passenger car and you don't like these trucks so close together and it's hard for you to reach your exit? And that is something we'll be looking at. At the same time, it in some ways the system creates more space for that because the trucks are clustered together a little bit more. But that is a question that's on our minds.
Okay. There is one short answer that you can give on that question. To what is the 4.5 fuel saving for the to what is the 4.5 fuel saving for the lead truck attributed to? I guess it's the turbulence behind the truck. But,
that's right. There's less turbulence immediately behind the front truck, and so that creates the fuel savings.
Okay. And then someone asked about the string stability about the platoon, but as long as you have only two trucks, the string stability is not too bad then.
That's right. That's right.
Okay.
It's really a non-issue.
But some attempts have been done with more than 2 trucks.
Right.
Okay, there are a few other questions. What I propose is that I will convey this question to you after the webinar, and then I let you answer them individually to the persons if you want.
Okay, happy to do that.
Okay. Okay. Well, with this, would like to close this session. I would like to thank you very much, Richard, and also Josh, for your intervention. I think it was very interesting, and I'm sure that we will have more of these kind of webinars in the future, either from US, Japan, or Europe, and other parts of the world. And this hopefully will extend our knowledge of what is being done outside our horizon. So thank you very much, Richard, and thank you for all attendees who will be so active. Thank you. Bye.
Thank you very much.